Hi, welcome back with Mr. Canada. We're looking at multiplying vectors, so the calculations behind them. So when a number occurs outside of our column bracket, on our left side, we multiply inside. Kind of like expanding brackets in algebra, and we've kind of did this already with our negative vectors. So this number outside is often referred to as scalar, or scalar quantity, right? So the vector is the inside, the scalar is just a multiplier, right? Because it just has magnitude. So here, really, this is really 2 times by 3, 2, right? Just if you can't see that. So we can bring that 2 inside to each term, right? Not just the top, it's 2 times 2, 2 times 3 on top and 2 times 2 on the bottom. So you don't have to show the calculation if you can just do it in your head. And you get 6 and 4. So next one, we're going to do negative 4 times 1 for the top, and negative 4 times 2 for the bottom, and we'll get negative 4 and negative 8. Lastly, we're working out negative a half of this, so I'm just going to draw it bigger, so negative 1/2 times by negative 2, and negative 1/2 times by 6. That'll give us, what is that? Negative times negative is a positive, 2 over 2 is 1, so 1. And then we have negative, because negative and a positive, and 6 over 2 is 3. Okay, so try these 6 questions. Pretty straightforward. Press pause whenever you're ready, press play, and then we'll go through the answers. Hey, welcome back. So let's go through these answers quickly for scalars. So we're going to get 4 and 2, because we're just doubling. Here we're tripling, so we're going to get 6. Whoops, it's not a fraction. My most common mistake is starting to put that fractional line. So here we get 6 and 9. Here we're taking times by negative 4. So this first one's going to become 4, and this will become negative 8. Next, we're having this all. So we can represent these as decimals or fractions. I'm going to choose just to leave them as fractions. This one. Now, these are kind of setting ourselves up. We're using a scalar to kind of solve, right? So we're bringing together a couple different things we've done. So let's first bring that scalar in, because we got to get rid of it before we can actually see. So inside the bracket on the left, we'll get negative 6 and 6. And that's equal to 2a and b. So we can say that a is equal to, well, 2 times negative 3 is negative 6, and b has to be 6. Okay. Lastly, one of these more complex ones. So we have negative 4a and 6b is equal to 4b and 12. Therefore, b has to be 2. And then on the top, if b is 2, right, we have 8. So then a has to be negative 2 to balance that.